Awesome. Okay. Test 1 2 test. All right. I think that we are ready to go. Let me just make sure everything is ready here. All right. Welcome. I hope that the audio is good enough. And I have the FPS set to 30 in OBS, so it shouldn't be too choppy. Except for if my game is going to be choppy. Seems okay. That's not great. That helps a bit. Okay. I don't even know what to talk about. I'm so worried about getting this working. So this is a generator. This is a server in creative mode. So we have creative steam. I think I need to turn off local loop back. Okay, now we're good. Yeah, creative server, so we have creative steam here. This is a steam turbine here, which is controlled by this signal processor. I'll start over here with the generator, I guess. So this generator, when it's spinning, it creates a voltage. Right now, that voltage is 3.22 kilovolts, according to Wayla, which is the box at the top there. And that voltage is measured by this electrical probe. You'll see I have it in voltage mode. The range is between 4 kilovolts and 0. So if the voltage is 4 kilovolts, it'll output 50 volts on the output signal, or a digital, an analog 1 signal when you deal with the signal processor, and then 0% when there's 0 volts. So that goes into this signal processor. You can see the equation at the top here, and it has some redstone in it for the computational power, I guess. And so basically the equation here is if C, and input C is this blue one here. If C is less than 0.8, so if you do the math, 4,000 times 0.8, you'll get around 3.2 kilovolts. And if this is the case, so if the voltage is below 3.2 kilovolts, turn on the steam at 0.5 or 50% output power. Otherwise, don't put out any power at all. So right now, the voltage is lower, or just about lower than 3.2 kilovolts, so it's spun up a little bit. It's spinning down now because the throttle is now down, but it takes a moment for it to reduce the amount of steam it takes in. So yeah, now the voltage is a little bit higher, so it's 3.25 kilovolts. So it'll just kind of oscillate over time, and if I were to put a data logger here, you would see it making, you know, almost like a very, very slow PWM signal. So some other components on this shaft. We just have your normal joint hub right here, which connects a shaft going this way with these two shafts here. These two generators, which are connected to this device here, is a current measuring tool. So when the current is 2 amps or lower, it'll output a 50 volt signal. If it's just over 2 amps or anything above that, it will output 0. And that goes to this relay here. So basically, if the amperage measured here goes over 2 amps, open the breaker. And then this inductor here, it has some copper cables and an optimal core in it. This inductor will cause a ramp in the amperage, so it will start at 0 and it will slowly ramp up. The more cable you have here, the slower it will ramp. So if you have no cable, this won't ramp at all, and this will just tick on and off constantly if you have high amperage. So yep, we have another set of generators here. It's basically symmetrical, with the exception that this side has a measuring tool and this side has a DC-DC converter with a 16:1 conversion, which is actually a new feature we just added recently. So it's converting 3.2 kilovolts to around 200 volts, and that's being fed into the lights in the building here. So you'll also notice a little contraption. This is symmetrical on the other side. You'll notice a little contraption here. So we have a joint hub, which connects all these shafts together. We have a tachometer, which is measuring the speed of the shaft. So if it's at 700 radians per second or lower, it'll output 0. If it's above 701 radians per second, it'll output 100. And basically that goes into this signal cable here, and then it goes into this clutch. And when the clutch gets a signal, it will clamp down on this clutch plate, and the clutch pin will lock it. And you'll notice I also have a switch here, which is pulling this line up, even if this goes down and turns off the output. So you can kind of think of this wire as acting as an AND gate. It keeps the clutch engaged. Same thing on this side. And the only reason that I have a flywheel on top of these, or quartz on top of these flywheels, is a new feature we just added. You'll see the generator, the turbine is spinning up again. voltage. Yep, the voltage is 3.19, and now it should turn off. Turned off, and now the fuel will go down. So that's what this is, because in the next feature that we just put out, the new feature, flywheels will actually fling players and other things. But for some reason there's a bug with creative mode where it actually gets you stuck. So to fix that for now, we just put some marble pillars on top. So some other stuff at this end of the shaft. You'll notice another tachometer and another clutch. This clutch, you'll notice, doesn't have a clutch pin, but it has a clutch plate. And we have a tachometer. So what this does here is the tachometer measures if we're going over speed. So if we're going above 951 rad per second, we're going to engage this clutch, which is connected to a fixed shaft. Think of this as basically, a shaft that is impossible to rotate, and visually it represents itself pretty well, compared to something like this or this, where you have like a bearing. This is mounted directly to the actual stand, so it's not going to be rotatable. We're thinking about changing the texture, but it's sufficient for now. And basically, when you have a really overspeed condition here and a stopped shaft here and a clutch in the middle, it will cause a lot of friction, and it will cause this shaft to slow down. This contraption here, so I haven't gone on the roof yet, but there's actually solar panels up there. So these generate some voltage, apparently around 470 volts. It is nighttime, so I wouldn't... Oh, it's just about to become daytime, so we'll wait for these to flip over. I don't know what the voltage is going to be coming out of these guys. Each of these panels is around 110 volts, so probably around 400 something volts, 472. Yeah, that sounds about right. And then that outputs to this very high voltage cable, which goes downstairs. So when the generator is starting, steam doesn't have a very efficient curve when you're just starting it. It has a good efficiency curve around the speed that we're running it at right now. You'll see it's 99.8% efficient. But at lower speeds, it's not as efficient to start. So we have a shaft motor here, which has another power inductor with one copper cable and a current measuring device and an AND chip and a relay and a tachometer. So basically what happens here is when we're under 700 rad per second, we'll output a 1 here. When this is not over 2 amps, we'll output a 1 here, which will turn on this relay. So basically, if the shaft is under speed and we are not going over current, close this breaker. And that will effectively allow this shaft motor to spin up this shaft. And once it's hit 700 rad per second, it will stop, and by then hopefully the steam has taken over. So this is where the poles come out of the building. A little bit of a visual bug there. They kind of clip through the wall. Out here we have some substations. So you'll notice I only have a couple poles here, and these actually don't connect across these substations. And basically what happens is this electrical probe here is probably set for 2 amps. Yeah, 2 amps. And then another one of those inductors. I put a couple less inductors in this one, and this isn't the most efficient design, but it certainly does work. And what this allows it to do is when you're setting up these grid transformers, it allows you to... Unfortunately, transformers have a lot of capacitance right now, so it kind of acts like a big... I would go past capacitor and say battery, and you kind of have to charge it before you can use it, because it'll explode otherwise, because it'll charge across these high voltage lines and cause an explosion because it's drawing too many amps at once and it blows the wires. So this right here is designed to slowly charge this up before you connect it to these big poles in a larger grid. And so this will basically act like a charge pump, I guess, is the term. Very similar setup here. Again, 7 copper cables, probably 2 amps. And this connects to the local grid, which is just some basic T2 poles. And right now, the only thing they power is this. At least in this direction, they go that way too. And down here, we have a 16:1, which is powering all of the lights around spawn. So all of the various lights here. This is the spawn point for the Lusty Lavender server. And so that's this direction. In this other direction, I'll show you my latest project. It's going to take us a minute to get there. So this railroad line runs over to our new 1 megawatt generator we're working on. And this line in this direction runs over to kind of like a gas pipeline we have. Let everything load in. So this right here is a oil rig of sorts. So basically, you know, this pump constantly is pumping oil. And then this plated flux fluid duct both powers that pump and brings oil back and puts it into this iron tank. And then it continues into the ground here. You can't see it, but under here we have some electrical age panels, solar panels, and a battery combined, which provide power to the actual pump. And it also provides power to a computer, which we are using in here. We have a special flow program we wrote. So right now there's no fluid flowing because we're not using oil. But effectively, this setup down here, what it does is it measures how much fluid is going through these pipes. In order to... that's weird. Why is this not working right now? Up close and personal to it. So here's the incoming oil line. It fills this tank automatically. The computer will turn on this. Does this just need a block update or something? There we go. So the fluid will empty out of this tank as fast as possible with this resonant servo. And then once this tank is emptied, it will take a little bit of time to determine how quickly it fills into this again. And it just watches how much oil is going through this tank with the OpenComptuers device. And yeah, basically it just measures how much oil goes through here. Right now, not a lot. Let's put this back. Inside here we have just your basic refineries, which apparently are full. So yeah, it looks like we're pumping fuel into this tank. And then pumping it into this train station here. Still a work in progress. So that's this area. And I would have more examples to show, but we just reset the server because the last one was kind of cluttered with older builds and we had some TPS problems. So here's where the oil is going to get unloaded. It's actually going to be refined, so this will be fuel unloading here. And then that'll go into this tank here. Unfortunately, it appears that we had an explosion because we forgot to put water in the boilers. We'll be fixing that. But if we go up here, oops, wow, 15 FPS. That's not good. So this floor is going to be where the steam turbines are. We're going to have more steam turbines in that direction probably. And then the power gets transmitted vertically. You'll notice we have these new vertical shafts kind of. They're actually just joint hubs put vertically, but vertical shafts. Can I go up here somewhere? Maybe over here. And so I can go up another floor here. This is energy storage. So we will have lots of flywheels. Lots of flywheels. This is going to be where the starter is located when we get there. Not a lot of space for it, but it should be sufficient. Then if we go up another floor, is there a way to go up around here? Go up right here. From here on up, we have sets of generators. And then above these generators, I think we have a control room. Where do I enter that? Maybe over here. This is going to be a... oh, we're in the clouds already. This is going to be a control room. And we're using SIGBUS here, so you can see different input signals. Mostly Grisses is working on this, so I don't really know what kind of progress he's making. But in the end, we hope to make a 1 megawatt generator. So that'll be cool. In the meantime, though, we still have a T2 pole bringing in power. This is how we receive power. So all the power comes in here. There's no like solar or anything. Goes in through this grid transformer, and then we push it through another one of these inductor chains. This one has 19. It could have 7. As long as it has a couple, it's good. You don't want to put no copper cable in these. And they don't work without the core. You gotta have a core. And then from there, we just have it dumping right into the lamp supply through a converter, 16:1. In this direction, we have one more build. Someone from the Electrical Age Discord actually built a wind farm. So on the surface here, I'll just go to the surface. We have the wind turbines. We have an anemometer, anemometer. I probably butchered that. Anyway, so we have wind up here, and inside we have storage for the power that comes in these batteries. And I think apparently there's a backup generator. Oh, probably for the lights. Yep, for the lights. Lights for the building. Here's some monitoring here. So we have the wind speed. These are the new digital displays we have. Voltage output. I think it's kind of stuck on the grid voltage. Yep. So this is the grid coming in from outside here. We have the poles coming right up to the side of the building. So the wire comes in, gets down converted. This is a 16:1, this is a 4:1. So this is 50 volt wiring, this is 3.2 kilovolt wiring. This runs directly over into this battery room here. Oh, it looks like we're actually disconnected from the grid right now. Yep, that would be correct. This room here, I think, is just some more, whoops, monitoring from the, I think this is from the surface, and then this is an output. Not very well labeled. This measures the temperature of the cable, so if it's going over temp, it will open this breaker. These are the probes that measure for those displays out here. I think that covers it for builds. So I'm gonna go back to spawn and figure out what's next. No comments on the YouTube stream. Okay. Yeah, I don't know what I should do really. I'll make a generator and spin it up. So let's grab some materials for this. I'm gonna grab a world edit wand. You have to be very careful not to world edit electrical age stuff, you'll corrupt your world. This. I already have one of these. This. And this. Okay. Let's see here. Where's a good spot to build? I think I'll just build another one over here. We'll make a 64 kilowatt generator. Maybe a test load. Okay. So each of these steam turbines can output around 8 kilowatts of power. I could do a gas turbine. Should I do gas? I'll do gas for this one since that one's steam. Or wait, no, it's like, it's 16 kilowatts on this, 8 on gas. Where's gas? Gas. Yeah, up to 9.72. So yeah, we'll do gas. Alright. So we will want to, I'm gonna put the gas turbines at this side. Actually, let's put the starter down first. So we have a starter, which needs one of these, so that we can measure the shaft speed. I did not grab a, I don't think it's called a joint, I think it's called a, oh it is called a joint. Okay, we need a joint. Just gonna grab a joint. Put one of these here and then we'll go this way with that. I'm actually gonna put a clutch and a stop shaft here, or a fixed shaft. And then in this direction we will have one, so that's 16, 32, 48, 64 kilowatts worth of gas turbines. That's just a rough estimate. And then in this direction I will put down joints. I want to make sure I have enough space for any kind of poles I need to put in. So So we're done with the gas turbine. Let me just grab this. I think I want 5 in each direction, so let's do it from a shaft, or joint rather. Joint hub. Okay. Well, actually, this is where the pole would. Yeah. Poles are gonna have to go here-ish actually. So 1, 2, 3, 4, 5. So we'll put it at 6. 2. Okay, yeah. So we'll put this here. Usually I do these in pairs because it gives space for wiring, and then I put them 3 apart. So this will be 32, and then I need 1 more set. I'm just going to put some clutches on these 2 shafts because they could be useful later. And we want to have 1, 2, 3, 4, 5, and then I think 1, 2, 3, 4, 5. Okay, and then this, these. Okay. And I'm going to bring this one in on each side so that they're not connected, because these poles, they can do, I could technically connect one on each side so there's 4 wires going into one pole, but this is just easier to split it up. So and then we'll have like that. And just in case we ever need it, I'm going to put a tachometer here. I'm actually going to shift this 1 block over. I'm going to put this on this side. I'm going to put this here. I'm going to put a tachometer and another clutch here, because I don't think that we need to always have that engaged, because it doesn't need to spin the shaft motor backward. Okay. And we'll need actually one of these here. 1, 2, 3, 4 should be good enough. I actually don't want this one, because I'll have a signal coming into the clutch from here. Yeah, something like that. Let me get a signal wire. Okay, so that'll be connected there. This will be connected here. This, I think we'll regulate these based on shaft speed rather than voltage on the generators, just to change it up. That does mean that when these generators are under load, they will be under voltage, because as you draw more power from a generator, the voltage output goes down per rad per second, kind of at a set rate. I think it's a linear rate. I've never actually tested that. This right here, let's configure these. So we're going to put this to 951 and 950. Always click validate. Okay, so that should output 0 volts because we're not spinning yet. If we go over to 951 or above, this would turn on. I need to grab some clutch. Oops. Don't need that many of those. Remember, this one only needs a clutch plate. It doesn't need a clutch pin because we don't want it to lock. This one can. These ones, since we're not going to use them, I'm not going to put clutch pins in, or clutches either. So that actually wraps that up. I'm going to need a temperate fluid duct. Just grab one from here. I'm going to run the fuel down this side here. I'm going to place this here. Change it. This is just a thermal expansion. Oops, I just got rid of my wrench. Need that. Oh, and I got rid of my creative tank. Jeez, I'm bad at this. While I'm at it, I might as well get oil, or no, fuel. Buildcraft fuel is sufficient. Okay, so we have that. Since gas turbines can't be started on their own, they actually have to be pretty much up to speed to actually do anything. This is going to look as though it's doing nothing right now. On this here, I'm going to set the... Actually, we should do this with a signal processor. So let's get some redstone. Redstone, redstone, redstone. Huh. There it is. I'm blind. And a signal processor. This one. So you'll notice input A is red, input B is green, and input C is blue. So this one, if we set it so that at idle, 1000 rad per second is the same as 4 kilovolts. We don't want to go over this many rad per second ever, really, because if you hit this or go over it, it'll explode. So in this we'll have if A is less than 0.8, which is 3.2 kilovolts at idle. Remember, it will go down if we actually use any of that power. 0.5 or off if it's above that. Press enter. 3 redstone required. Put in 3 redstone, and that's good to go. So you'll see it's 25 volts because it wants to run those. Unfortunately, these gas turbines can't run until the speed is up, which is what this will do. So we'll configure this guy. This is going to be on at anything below 650, and at 651 we will shut off. You'll hear that it just latched the clutch. That's what that clicking noise was. And so let's see here. Do I want to power this up from the other one? Might not be a half bad idea. We get some poles in place. Okay. Connect these. I don't want to connect to this yet. We don't need any of these anymore. Kind of done with building the shaft. Now we're going to need these. We're going to need some cores. Need more of those. Let's see here. Gonna need some high voltage cable, relays. We have signal cable? No. Gonna need some signal cable. And I think we're gonna need at least an AND chip for this right here. So this actually is going to have it's going to have 2 inputs. So we're going to have that like that. We're going to have I'm going to run this around. And the reason is that I want to engage this, put that there, then I want a probe here, and then I want an AND chip here. So the 3 inputs to this AND chip are going to be the amperage coming in, this side here. Oh, this is actually an input to both of these. And that's going to be a button. So I want the one that acts like toggle switch. So this one, basically, you can turn it on, it'll stay on. You turn it off, it turns off. So that'll enable power going into this and allow this to lock in the first place, which gives us a method to turn this entire contraption off. So I'm going to put this in there. I'm going to configure this for current. 2 amps is okay. 2.0 amps is when we turn off. You'll notice that this line here is 50. And if I turn this on, it'll turn the relay on, and it would turn this on. But it doesn't make a noise after it's been clutched once. Okay. We will put a core in here. I will put let's go with 8. 8 sounds good. Okay, so this starter is good. This is prepared. Yep. This is good. So we have all of our stopping, starting mechanisms, safety mechanisms, power. So we just have to wire these up now. Let's grab, we're going to need these. We don't need these. We're going to need these, but I usually just keep those out of the way. Alright. So we're going to have this here, these here, this here. Each line is going to independently be limited to 2 amps. These guys here, this here, that there, and then we have signal wires that go in. This is why I separated those by 1 block. Okay. We do have the config copy tool, but I was having problems with it. We can try it and see if it works. Shift and left or right click to copy, right click to paste, and I think that copied in okay. Remains to be seen. And on these, I'm just going to do them by hand. So we'll put in that, put in that, put in that, put in that. Okay, this side is done. Let's connect these up. How do I want to connect these? I won't actually be using that. I'm going to put a small substation here, maybe? I don't know. I think I'm just going to connect these poles up and hope they don't explode from too much load. We'll run this through a dedicated pole over here. Connect these together. This to this, connect this to that, not too bad, connect this to that, connect this to that. Oh. There we go. And hopefully that's not too bad. Okay. Looks like it might actually be backspinning these. Indeed it is. Alright, I'm going to turn this on. This might be too much. It is. So the generators are kind of inefficient at spinning up shafts, so I'm going to leave those disconnected for a moment. I could put an AND gate here and then some buttons. Or I could use a wireless signal to do that as well. Let's take one more out. We can actually up this to 4 amps, because these are known to use a lot of power, and there's not too bad here. Okay. Everything looks to be running properly. And I think I can take out the final one. See how much power is going through this. Oh man, that's a lot. I might want to put one back. Unfortunately, these power inductors are not as accurate as I would like. We hope to fix that soon. Okay, yep, now it's drawing less than 4 amps. It's probably still in the vicinity of 16 kilowatts, 12. Okay, I can hear these generators spinning up now. 529. These will turn on around 630 rad per second, and then they'll spin up. So pretty soon. And I think we configured this to shut off at around 650, so that should be good. Once that turns off, I'll put these wires back over here. Six 605, 609, 611, 612. $632. Okay, and the gas turns on. This should turn off, as it does. And now I can shut this off, which will remove power and make sure this clutch is off. Okay, and it's up to speed. These are generating power. Let's see. 756. The load is being split between these two generators now, and also any other, like the wind might be, actually the wind is disconnected. Yeah, these two generators are both putting in, perhaps not exactly equal, but they both aren't very accurate when it comes to voltage regulation, so they will fluctuate a little bit. putting some monitoring on the shaft speeds and the shaft voltage and the proper voltages coming out of the system may reveal more information about how that's working. So I just came to the realization we never actually put any flywheels on this shaft. So there's a way we can remedy this. So if we take that out, put an AND gate here. Oops. The white dot is the output side, so this is the output side, and then these are two input sides. I actually want an OR gate here, because I want it to be one signal or the other, not both of them together. This one. Okay. So now it'll be this or that. And this stuff's all handled, right? So we have to get the shaft down below 200 rad per second. Apparently it brought it right down to 0, so as it would be. The generators are actually trying to start this, so I'm going to put that on. Put these two in place. Untrigger this. Turn the starter back on. We definitely want to put that back in. And now, so that's spinning up. I'm going to put flywheels on these. And we can turn them on when we're ready. We'll definitely want a signal switch. And we put in the clutch pin and the clutch plate. So once this shaft is back up to speed, we can try putting these flywheels on. Slowly. We might actually want to use a signal trimmer to bring these up to speed, because you can actually control how much input voltage is coming in, or how much this is clutching, rather. Okay, we're up to like 400 almost. Getting there. I'm just going to let this actually spin up like that. I'm going to put down wiring on the other side while we wait. Okay, those. Measuring tools. Turn on at 2, turn off at 2.01. Get the copy tool. Shift right click, right click, right click, right click. Then we put in the wires. And we want signal wires as well. We want inductors. What did I do on these? 8? 8. Okay. There we go. And we just hook these up. Wow, filling my inventory right up there. If that's drawing current there. Getting there. 520. 545. I think I can take that last inductor out. Yep. $580. Oh, now we're really starting to spin up. $590. It's kind of funny how Wayla doesn't show the speed of the tachometer. Should show the speed, energy, voltage, output perhaps. Maybe even the range details. 613, 616. We're just about to the point where the gas is going to turn on. 627, 629. Okay, gas should be spinning up now-ish. Yep, there it goes. Alright, so this is done. That's spinning up to speed. So now I'm going to start to turn this on slowly. Let's go with 2%. Okay. So you'll notice the one on the right is the speed of the flywheel, and the speed on the left is the main shaft. Funny enough, the main shaft weighs twice as much as the 5 flywheels we're adding. Okay, and it looks like we're just getting to a point where we're gonna sync up pretty soon. And it should click in place once it has, and then we can turn on the button on the other side to keep it locked. Okay, nearing locking speed. Locked. Okay, you'll notice slipping is no now instead of over here where slipping is yes. And we turn on full clutching voltage. Put this back down to 0 for the next time. And we'll do the same for this side. And try upping the clutching power a little bit. Just about clutched. There we go. Lock. Off. Alright, and we're back up to speed as usual. Alright, so we can try putting a load on this thing. Let's see here. About up here. let's see, things that I want later. Those. That. Okay. So now I'm going to set up some rheostats, which are basically big resistors. Set up 4 of them. So I'm also going to need this and this, I think. Oh, and we're definitely going to need some signal trimmers as well. So let's start off just by making a toggle switch for all these. I'm going to want to switch as well then. Okay. So this will allow us to easily turn on and off our different loads. And now we're going to grab some small thermal dissipators, large rheostats, lots of coal dust, and a ground pin. I'm going to need these to connect this to the grid as well. This should be able to run through one pole without exploding. Should. You'll notice that when I connect these, you'll hear the generator spin down a little bit because it's filling the capacitance of those wires. This is one of those reasons that we need those relays. You'll hear them click again, maybe. Nope, maybe not. Alright, so we've got those wired. Don't need that anymore. So we will grab large rheostat, ground cable. Let's put the rheostats here like this. I usually do them in pairs. Gonna want some wires. Put a wire there, put a wire there, put a wire there. Ground cables. And some small thermal dissipators. Should be sufficient. Technically you can sink 4 kilowatts, which is what I'm going to do on all of these without thermal dissipators, but it just peace of mind. So each of these needs 56 coal dust. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then just one more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, don't need those. Oh wait, I need one more set. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, last set. Alrighty. So we have put coal dust in all of these. I'm going to put signal trimmers on all of these. Put them up to maximum. I'm actually going to put signal wires in place. Still going to put it up to maximum. Oops. There we go. I don't know how to use a mouse. Okay, and signal wires. You'll notice on the rheostats you actually see the resistor needle fly around. So putting them at full resistance will increase the actual resistance. So if I lower this, it'll lower the resistance to 12. Raise it, it'll go up to 47. And I think that makes us ready. Alright, let's turn on this load and see how much draws. 34.2 milliamps, that's not too bad. Let's up it. 136 watts, 206 watts, 265, 618. Let's go to 2%. 1.84. 0. 5.49. That may not be sustainable. I'm going to put it at just 2%. I'm going to put all these at 2%. Okay. 3.72 kilowatts. So I'm going to remove this pole here. So now it's on its own. That means that all of the power that is going into this pole is coming from the generator. And I'm going to up the power here. 5, 10. Let's see how it handles that. Just fine. And this will make it just around 15 or so. Should make it just around 15. Maybe the voltage is a bit on the low side. Oh, I never turned this on. Let's turn that on. Okay, see how it's doing now. Okay, yeah, now it's under much more of a load. Let's see here. 30 kilowatts, that's much more respectable. And I said this would do 64. If you want to do 64, you're going to have to up the current to probably around 3 amps on these electrical probes instead of 2. But it's totally possible. I usually just do 2 because I like to play it on the safe side. And I over-provision my generators. But I can easily put another row of these up. Let's see here. We'll put some more in. Let's play that safe. Okay. We'll place some more rheostats down. 159. Is it stabling out about that? 177. Yeah, I'm not sure. Alright, let's place some more rheostats down. I think that's about the same spacing we were doing. So if that does 30, this should do around 60, which will be just 4 watts under, or 4 kilowatts under, which is okay. I don't really care to make one to do that last 4 kilowatts. We can place these down. 64 kilowatts is going to be a decent amount of power, so I'm going to want to put in a second pole to run power to, and run to these 3. Gonna need one of these as well. Hopefully this spike doesn't hurt the poles. It may. I can turn down some of the load. That might help a little. Okay, and connect this to there. Connect this to there. Oop, so now we just went over 2 amps, so it's doing the thing there. That might do it as well. Yep, now the amperage is going down. That's what happens when you have really high capacitance poles. Kind of a bug, to be honest. Alright, let's put in these breakers here. One more over here. And we need to put in rheostats and coal dust. Oops. All right. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay, so I have 6 stacks of 56 again. Gonna put those in. Okay. So those are in. Let's put a signal switch in on all these poles so we can turn them on and see if we can cause an explosion of the poles, because that's likely. I will need to up the current on all of these, actually. This is going to need to be up to 3 in order for this to work on all of them. Let's see if the config copy tool will do it for us. Alright. Hopefully that worked. If not, we'll know. Because it won't be able to turn on all of them. Hopefully I didn't forget anything. Nope. Okay. Let's see what kind of load we're pulling now. 1.57 amps. Let's put another one on. Let's let the gas turbines recover a little, I think. I think that's not going to recover. Okay, not rated for 8 kilowatts then. Let's see what this is for load. Is it spinning up again? No, it's continuing to slow down. Because of the efficiency curve, this will not spin back up unless it gets a chance. Oh, you know what? That should allow them to spin up to full speed so that we can actually get the full rated speed out of it. So like I said, when the speed goes, when the power goes, let's try again. When the number of amps you're pulling increases, the nominal voltage decreases on these generators. So you'll notice the speed is 800 rad per second, but the voltage has dropped from 3.2 kilovolts to 3.08. That'll continue to drop if we drop more current. So let's turn on another one of these. So the speed is the same. About the voltage has dropped to 3.04 instead of 3.08, and the current has gone up. Let's do it again. Okay, now we've pulled the voltage down to almost 3.0 kilovolts. Current is over 2 amps, slightly. And we can try pulling on the last one. Which means we should be drawing 64 kilowatts. The voltage has dropped to 2.97. And let's see, so each of these poles is going to have 30 kilowatts on it, because each one is running each set of resistors. Not bad. We can try increasing the speed. That'll increase the output voltage. Because of how loaded the turbines are, and because the efficiency goes down as they spin faster, it will eventually hit an equilibrium point, and it won't be able to increase speed anymore, which means it won't be able to increase the voltage anymore either. I'm guessing it will be before the point that it can go to 3.4 kilovolts worth. Or 850 rad per second. And that 3.4 kilovolts worth would be if it were actually measuring the voltage and not the speed. Looks like you can actually handle it. The amount of power we're drawing through these poles should increase. Yep, 31. Let's put that up to 4. It's a bit on the loud side. Okay, so we should see the shaft speed increase more, and maybe we'll get up to 3.2 kilovolts and see the 64 kilowatts of maximum load that I think we can get out of these. Meanwhile, 184 degrees Celsius, 165, 166, 166. I wonder why that last one is warmer. Both have 56. Huh. Who knows? Okay. It's definitely slowing down the speed up. I don't think it's actually going to get much faster than this, actually. Which is kind of unfortunate, because, oh, well, it might actually be hitting the estimate I had. Okay, it's 64 kilowatts. It's going to have a very difficult time increasing in speed any further. But that's what a 64 kilowatt generator looks like. Pretty effective. Gets the job done. It's got some flywheels too. If I turn these flywheels off, it might speed up a little more, because it doesn't have to pull these up to speed, although this is only about half the weight of the entire system. Whoops. This is that bug I was talking about. If I put myself in survival mode, you'll see that it flings me and gives me some damage. Or it just kills me. That works too. Death.attack.flywheel. It should just fling me, but I guess I was stuck because I was in creative mode when that happened. Let's... Okay. Should fling me. There it goes. That was what I expected to happen. So yeah. Is it going any faster? 855. That's just over the 64 kilowatt mark. I guess my estimations are correct. At least if you can get every ounce of power out of them. Now, if I turn some of these off, the gas turbines are nice in the way that they will, they will not overspin extremely badly. It's going to overspin, and it's actually going to go at least up to 900 rad per second. Potentially over. Yep. So now the gas should have turned off. Yep. And it'll continue to spin at that speed. That's going to heat this up a lot. Let's turn on some of these again. And see if it can output more kilowatts of instantaneous power. 34 plus 34, so that's 68, a little more. And it's going down, obviously, because the shaft speed, it absolutely cannot keep up. I can get rid of that death point. Oh. I do remember going over there. I can look at that. Someone else made another build. Could go look at that. Let's actually just teleport there. So this is a village. So I'm going to go to the power plant first, which is just over this hill. It's actually, if I recall correctly, a relatively small power plant with a relatively small output size. I remember when Grissus and I were working on it, we had some output voltage problems where it would occasionally trip the circuit breakers. Oops, I'm good at this. Occasionally it would trip these circuit breakers. Oh, it appears to have done that. Okay. For some reason it trips these circuit breakers, and it's unknown as to why that happens. And I think now that we've done that, these turbines, which are providing all of the power, should spin up. 228. So these are coal-fired? Coal-fired. And they're getting the coal from over here through a chest. Interesting. When does that turn on? Only when the heat gets to a certain point. Okay, neat. So yeah, if this gets up to 25 degrees or more on the output side, it will turn on this fan. Cool. Doesn't look like it's going to do that. So this is some SIG bus cable here. That black is really hard to see. Looks like it's going to these displays. Turbine voltage, turbine current, turbine power, stuff like that. Some batteries up here. Let's see if these are tripped or not. They look okay. That's definitely not the correct voltage. And this one's open too. Oh. Is that gonna trip? Yeah, that tripped this one. Which tripped this one. This is actually kind of comical. .23 amps of power. So I'm going to let that charge up these batteries because apparently they're pretty empty. I'm actually going to pull these breakers out. They're not helping right now. Oh, fun fact. If you place a cable, you'll notice it doesn't want to connect. If you press C and right-click on it, you'll change the color care to 0, which will allow different color cables to connect. Cool tidbit. I'm going to change it back and put it blue here. Whoops. There we go. And let's see. This is bound to be a temperature-based. Yeah, it's going to prevent this from pulling too much current through and blowing the wires. Because what will actually blow these wires, besides the voltage level protection, so like if it goes over, you know, 62 volts, it'll explode. But the only other protection, it doesn't actually check amperage or watts, it checks temperature of the cable. So if the temperature of the cable goes over a certain amount, that's what causes them to explode, not the amount of amps. You can have very high current, like this cable's rated for 200 amps, but you'll notice that it peaked up to 201 amps, or no, it's rated for 20 amps. It went to 21 amps, and that's okay as long as the cable doesn't overheat. Okay, so now these are coming up to voltage. Let's see if I can turn these on. Maybe ill-advised. Yeah, open the breaker again. I'm effectively doing what those automated current measuring devices do. I'm actually considering putting one of those here. Oh. It has one. 1.51. Let's just do that. I'm going to bypass this with a switch for now. Let's see here. I want to probe. And if we... there's not going to be relays of that voltage here. This and this. So we're going to put this here. I could put a coil, but there's already one out there, so I don't think I need it. Because this is coming in from a low voltage cable, this can only support 1 kilo. Oh wait, this is medium. So 2 kilowatts. This can handle 15. So I think around, let's try that just for starters, just to make sure we don't explode the low voltage end of things. And we'll go from there. What's going on? Okay. Yeah, that's definitely heating that cable up too much. Wow. So I'm going to have to turn off some load at the other end of this transformer cable and stuff, because it's clearly drawing too much power for me to be able to get this up to voltage. As the voltage increases, the current decreases, which is why once the voltage has been established at a proper intensity, it will proceed to work. But until then, it will draw too much power. So let's see, there's an electrical panel down here. Yeah. Okay, so we can turn off here. Might have the breaker's probably outside. Oh, it's probably down here. Okay. Here we go. Switch that off. That's 2 out of the 3. Oops. That's 2 out of the 3 buildings. I think that'll be sufficient to get the voltage up. And clearly I also need to lower the current on that one automated circuit there. So this one here, I'm going to do 0.1 and 0.05 amps and connect it again. Now I don't know why this isn't working. Okay, now it is. Okay. I'm going to let the voltage recover on this line. This would do better with an inductor. It'll limit the current going through the system. I'm going to put something that measures the current here. Actually, let's do power. it's going to be way over what this graph shows. Put this sampling down a bit. That is going to cause yeah, that's 15 kilowatts. Now you can actually see the curves created by that. This I want to put to 15 as well. Put this to kilowatt mode. Okay. Yeah, so you'll see it ramps. I can pause this. It ramps up, and then once it finally gets to that 2 amps or so of current, it cuts off, and then it charges up again, cuts off, charges up again, cuts off. And inductors in the real world are supposed to kind of retain some of that charge as they drop off. But in electrical age, it kind of just loses all of that. So yeah. Let's see how that goes. So we're getting up there a little bit on the voltage on this side. Somehow the voltage on this side was higher. I think this voltage here is just fluctuating a lot. Put this to 5. That's what happens when you press enter but don't click validate. Wow, those are dips to 0. That's not good. Is that 2 blocks thick? Yeah, I guess it is. Let's see what the voltage is coming out of here. 227, 226, 227. Oh, here's some graphs. How are we doing on battery charge? So the overheating circuit is actually protecting these from charging because they're trying to charge too fast. Probably need a serial resistor for this. What on earth is going on here? I think we can put this up a little bit. It won't affect it too much. What's the voltage here? 2.86, 3.05. Let's increase the range here to 3,000 and 4,000 volts. $2,500. There we go. Universal meter. There we go. Looks like the tier 2 grid voltage is 50.5 kilovolts. It's just a little bit low, but sufficient. I do, however, find it interesting that this isn't quite close yet. Might be worth trying that. Okay. Yeah, I figured we were nearing where we needed to be. 6.7 amps there. Don't need this inductor in that circuit. Kind of confused as to why this one's providing more amps than the other one. Huh. Interesting for sure. Let's go back to the village and see what the voltages are looking like down there. Maybe I can turn the lights on. So this is the other grid room here. 54 kilovolts, not bad. How many watts? 317. Most of that is going over here, I would believe. Maybe not. Into this house we go. We'll turn the breaker back on. Should oh, the light's on. 150 watts. Hey, look at that, light is on. Got some lights back here. Apparently there's a light down there. Not too shabby. Turn the power back on in here. $23 milliwatt. It's probably because these the machines are not on. All right. Step out and see how the circuit looks at the other end. Now that we've turned on more stuff. Oops. Still bad at that. Looks good. Interesting. So the current... That's weird. What is going on here? I don't know what the objective of this is. Power. This one has it in voltage mode. This one has it in power mode. What do you say we put this one in power mode? Why? That diode's not working, right? That'll prevent us from blowing up some of those cables right here. Oh, actually, I need to do one here as well. There we go. Very strange. Yeah, I got nothing on why this exists. Start. So it transmits from here to there. Okay. Interesting. Well, that's about all I got. This is a little bit away from spawn. Let's see how that generator we made earlier is working. It still exists. Yeah, leveled off at 855 rad per second, so I think that's as fast as it can go under this kind of load. 32.1, yep. Does it give us more precision if I... no. Alright. That's neat. And these all level off about the same. Yeah, I'm not sure why those are different temperatures. What's the normal grid look like? Normal grid looks normal. Alright. Now I just gotta figure out what to do with this space. Not today, I guess. I think that wraps things up.